Most mornings start the same way. Coffee or tea, quiet, a quick look at the system's logs. This week, our Homelab is growing. Last time, we brought up the Proxmox server, which I aptly named Andromeda. Today, we're launching its first satellite, Callisto. You see, before we can get into all the Kubernetes goodness, every network needs a foundation, a way to translate names into meaning. We're building that today with Pi-hole and Unbound, a recursive DNS stack that gives this Homelab a mind of its own. Let me explain. Before we get started building anything, let's talk about what DNS actually does and why we're creating our own. So every time your PC connects to a website like, youtube.com/Crowbar kernel panic, it has to ask the question, what is the IP address for this domain? And what usually happens is your PC or this really represents any device on our network reaches out to our router, typically by default is connecting to your ISP's DNS. Or if you've changed it, maybe you're connecting directly to something like Google or Cloudflare. But in any case, your router has to forward that request to a DNS. That DNS server, be it Google or Cloudflare or your ISPs, is then reaching out to a root DNS server somewhere on the internet, getting the information from that authority. You're able to reach youtube.com/Crowbar kernel panic. So that's where Pi-hole comes in. I'm sure you've heard of Pi-hole before. We're gonna go further. We're gonna go deeper than that. So just stick with me. But just as an explainer of what Pi-hole does, add Pi-hole here. Our PC makes a request to our router. We'll change our router's primary DNS to be the Pi-hole. So it will then send it to the Pi-hole, where Pi-hole acts as a filter. It checks each request against a known ad and tracking domain and blocks the ones you don't want reaching the outside world. As long as it doesn't match anything in that bad list, then it forwards it to the same DNS that we were discussing before, either your ISP or Cloudflare or Google or whatever you set. Within Pi-hole, you set which forwarding DNS you want it to be. And then from there, it goes to the outside world. Now, how are we taking this one step further? Where we introduce Unbound. We are going to set up a server running a service called Unbound, and we're going to set that as the forwarded DNS for our Pi-hole. So whenever our Pi-hole doesn't know the answer to the request, it's going to forward it to our own DNS resolver, Unbound. Unbound going to completely skip this step of reaching out to an external DNS, and instead it's going to go directly to the source. It's going to look at the root DNS servers and walk the entire chain to get a trusted answer for DNS resolution that we completely control and is on our network. And then it's going to cache those results for any future requests to resolve much faster. This is where Callisto comes in. What we're building today, a server that will house both of these services. So in this Homelab, we're building this entire chain on Callisto, our first VM service on Proxmox host Andromeda. This will be the foundation for everything else that we build in the future. Our Kubernetes cluster, internal services, even external reverse proxies later on. With DNS handled, every future project will be a lot smoother, we'll have a solid base to stand on. Now, in this Homelab, I have a low tolerance for doing anything more than once. We want to automate, future-proof as much as we can. So we're going to be using Ubuntu Cloud-init, Ubuntu Cloud VMs. And so I'll start off this demonstration by showing how to create those now. But this paves the way for future automation that will be in future videos. So if you're interested in Cloud-init, consider it a bonus to this Pi-hole Unbound video. Let's get started. Make it easier for you to follow along at home. I've actually taken all the steps of this and put it in my GitLab project. And to make it easier to translate to GitLab, we're going to be performing all these steps in the terminal. You can do all these steps within the UI, but I find it's easier for me to illustrate what's happening and explain each step so that you can follow along. It's easier to do it all in the terminal. So the first thing we're going to do is we're actually going to open an SSH connection to our Proxmox server. So we're just going to look at the exact same IP address that we have hosting our Proxmox, and we're going to SSH to that and whatever SSH tool you would like to use. I am using MOBA Xterm because I have a license. I use it at work, and so I'd use it for this also. Anything will work though. First, I'm going to be downloading the official Ubuntu Cloud directly from Canonical. This version of Ubuntu is built with Cloud-init, and we can utilize that in the future for our automation. But it just means that it's designed to be automated from the start. I'm placing it in Proxmox's ISO directory, so it's easy to find and reuse later. Now, I've actually already done this step. As you can see, I already have the image here in this directory, but if you're following along and you've not done this yet, you'll actually have to run the wget command that I have step 1 of the instructions, which will download the image and place it in the folder. Next up, I'm creating a new virtual machine. This is going to be ID 9000, and we're going to be naming it Ubuntu template. I'm giving it 2 CPUs, 2 gigs of RAM, and using VirtIO network adapter, which is fast and efficient for virtualized systems. The BIOS is set to OVMF for UEFI boot, and the Q35 machine type ensures good hardware compatibility. I actually mistyped this command a few times because OS type is L26, not 126, so I had to do this. And the second time's a charm. Just copy and paste from the GitLab, trust me. Okay, here I'm importing the Ubuntu image, and we're going to be essentially turning that Ubuntu image into a storage disk that can be used to boot our Ubuntu Cloud VM. This basically takes the image file that we downloaded and it turns it into a virtual drive that we can use for the VM to boot from. Now that we have that new virtual disk, we're going to be importing that and attaching it to the VM using the SCSI interface. That's what I'm doing here. This links the image file to the VM so that we can actually boot from it. Now I'm adding a Cloud-init drive. This is what Proxmox uses to actually inject that data that I was talking about earlier. So things like the SSH key, the host name, the static IP address, all of these things can be injected automatically anytime we build a VM from this Cloud-init template. This is what makes that possible. Here I'm adding the EFI disk. This is because Ubuntu Cloud is going to be booting using UEFI. So without this step, it wouldn't boot properly. Next, we're just setting the boot order. So here we're enabling the QEMU agent. This is something that Proxmox uses to be able to communicate with the VM directly. It's a service that runs on the VM that acts as sort of like an admin console for Proxmox itself. It allows things like graceful shutdowns, IP reporting, the Cloud-init status. Proxmox is able to view and use because this service is running on the VM. So here we're actually resizing that SCSI disk. By default, Ubuntu Cloud image is tiny, only a couple of gigs. I'm resizing the virtual disk to 20 gigs so that we have room for updates, packages, and future expansion. Actually, if you don't do this step, your first boot will probably fail because there's not even enough space in the original image for any initial updates and stuff that take place on the first booting. This will prevent that error. 20 gigs is just a guess on my part. Seemed like a good place to start, and I'm not sure if it should be smaller or if it should be larger, but 20 has been working for me, so I'm going to stick to that for now. Okay, and now we need to actually make this VM we just created an actual template. Okay, so now that we have that template built, we go to the Cloud-init tab where we see a set of settings that we can apply to any VM that is built from this template. So I'm not going to go through all those here. We're going to use that in a future video, but what's important for right now is that I'm going to input my public SSH key to make it easy to connect to it. Next, we can define DNS settings. In my case, I'll point to public resolvers for now, but later everything in my Homelab is going to resolve through this VM. Okay, thanks for going through all that with me to set up Cloud-init. You can just make VMs and install Pi-hole, but I really think that this sets us up for more things in the future, and we're going to cover it more and use it more in future videos. So thanks for bearing with that portion of the video. Now on to building our first VM. Now, because we've done all that work up front in creating our template, watch how fast this goes. So with our Ubuntu template selected, I'm going to right click, clone. The name we're going to give it is Callisto. It'll be a full clone. That's the safest. We'll select our local LVM. We'll stick with 100 for the VM ID. I don't really have a plan for that. And clone. Bam. Bob is your uncle. You've got yourself your first cloned VM. It's still building right now. It'll come up and say the name of the VM. There we go. Callisto. How fast was that, people? All right, so going through the settings, we may need to change a few of these. We'll go ahead and resize this hard disk. We're going to put 20 gigs here. That means an additional 20 gigs, so it'll go from 20 to 40. Yeah, we have that 40 gigs. Now here we want to verify that our DNS is set to the same as what we had in the template. And then also we're going to give this a static IP. And I'm going to define this static IP in my router to always assign this lease. Now that we have that configured, we should be able to boot it up for the first time. Because it's Ubuntu Cloud, it'll do a lot of this automatically, but I still like to run your typical first starting updates and upgrades and go ahead and go through all that rigmarole. Then we want to install that QEMU guest agent. Click OK. All the default settings for this are basically normal. And that's it. We have a working VM. This is our first satellite for Andromeda. Now, let's get to installing Pi-hole and Unbound. Okay, the first thing we're going to do is we're going to install Unbound with apt. Click OK on this. Which service should be restarted? Okay, actually we can check all of these except for user at 1000.service. This is actually part of the QEMU service, and we don't want to restart that. I get an error message after this screen because I did that. It won't hurt anything, but if you want to avoid this error, then don't check that one. Okay, so now we have Unbound installed, but we need to do some configuration. Let's go ahead and make a directory under var lib unbound. Next, I'm using wget. We are going to download the root hints file. This file tells Unbound where to start when resolving domain names. Basically, it's a list of root DNS servers for the entire internet. Because we're using Unbound with Pi-hole, we need to create our Pi-hole configuration file now. Now I'm jumping into the Unbound configuration directory. By default, it comes with a few sample files, but we'll be creating our own specifically for Pi-hole. Now we need to create a new configuration file, pi-hole.conf. We're going to paste in settings, and then we'll cover the key parts. Let's break down what's important here. This top section is where you set where Unbound is going to listen for requests. And in our case, because Pi-hole is living on the same server as Unbound, it will just be localhost on port 5335. The root hints line tells Unbound where to start its lookups. These are those root DNS servers that we discussed in the beginning of the video. The rest of these settings are either DNS security settings or they're just caching and tuning. Essentially, all of these settings will work across almost every system. Now I want to rename the original Unbound config file because we don't want Unbound to try to load both configs. Okay, now it's time to start the services. First, we're going to start the Unbound resolve conf. This service handles DNS updates and keeps Unbound aware of any system or network changes. Finally, I'm starting Unbound itself. Now, you'll see an error message on my screen. You can ignore that. That's because when I originally started the service, I didn't have that unbound.conf file renamed. And so it tried to load both configs at the same time. If you follow these steps as I've done it in the video, you won't get this error message. But this is the actual Unbound service itself, the one that's going to be recursively looking up the DNS resolutions. So that's it. Now that we have Unbound running, we just need to install Pi-hole, which honestly is the easiest part of this video. So let's go ahead and jump into that now. Okay, from here, we're going to go ahead and install Pi-hole. So the installation of Pi-hole is a curl command that is going to pull in the Pi-hole installation. Pi-hole installation is pretty straightforward. We're basically just going to be clicking OK and next, and there's a few places we need to put something in. This is just warning us that we're going to want to use a static IP address. So on this screen, this is where we're selecting our upstream DNS provider. If you don't use Unbound, then you're going to want to use Google or something else in this list. For us, we're going to be using a custom DNS provider because we're going to be using our own. And then here, because we are forwarding to ourselves, we're going to use this 127.0.0.1 at 5335 for localhost. Okay, on this screen we can just show everything. Yeah, our installation is complete. We have the IP address for our Pi-hole, and we have a IP address on port 80/admin to log in. And it even gives us a first-time password. You should, of course, and of course I am changing this password. We'll log in first just to make sure it's working. You see in the top left, we have a red alert there for the DNS server failure. That's because we haven't fully set up Unbound and started it yet. Now, the way we reset that password is back in our terminal, we type in Pi-hole set password. You have to run it as sudo. And here I am changing my password to something super secret, I'm sure. Let's address just a few cleanup items before we close this out. The first thing is within Proxmox, I want Andromeda's DNS entry to match that of Callisto's. So here I'm going to make sure that it's set to the same IP address as Callisto's primary static IP address. So we've changed that. Also, within my router, I've set the primary and only DNS. It's not forwarding anywhere other than to Callisto. So all the traffic on my network should be routing through this new VM we just created, as well as any devices on my network that may handle their own DNS. I'm going to point to either the router or to this VM specifically. So finally, the last thing that we want to ensure is that these services are enabled. So whenever Callisto inevitably gets shut down and powered back on again, it will enable these services and disable the original DNS resolve service. So we'll go through those together right now. We want to make sure that Unbound is enabled. We want to make sure that Pi-hole FTL is enabled. We want to make sure that Unbound resolve conf service is enabled. And we want to make sure this is only going to be if you're running Ubuntu, especially Ubuntu Cloud. But we want to make sure that the system resolve D is disabled. It will try to use the same port as Pi-hole. So if you're doing the Pi-hole installation and this service is running and you're on Ubuntu, you may run into a scenario where you have to actually disable this service before doing the install. But otherwise, after the installation is complete, just make sure that it's disabled and you're good to go. All right, so that's it. We have a working DNS on our network. This will be the foundation for everything we build going forward. Next episode, we're going to be establishing that Kubernetes setup, and it may look like I recorded all of this in one day, but this actually took 2 weeks, and I wore the same shirt every recording, and I haven't washed it yet. So I'm going now to change. So I'll see you guys in the next video. Peace.
Understand. Crowbar, Kernel, panic tonight. Breaking through the system's fight. Glitch and grind, we're taking the ride. Crowbar, Kernel, panic, we won't hide. Packets flying, wires hum.